Okay, so very good morning, good afternoon, good evening to all of you. In this video, we will discuss means how to predict the delivery delay. Okay, so we have some independent variable like delivery distance, traffic congestions, weather condition, delivery slot, driver experience, number of stops, vehicle age, road condition score, package weight, fuel efficiency, warehouse processing time. And here problem is whether a delivery will be delayed based on the operational factors such as mentioned here, and delivery slot also. So on the basis of that, I just want to predict delivery will be on time or it will be delayed. So here the description in our data set is given: vehicle age, age in the year, road condition is given, and that data given 1 to 5, actually rating given, package weight, the total weight of the delivery in kilogram, efficiency of the vehicle is given, warehouse processing time means the time taken to process the order at warehouse, that in minute is it is given. So like that some variable is given, so that I will discuss. I will import the data into the Google Colab, and then also I will do the deployment and make one app. With the help of that, we can predict we are able to deliver on time or not. Okay, so in this Google Colab, I will first import the data. Okay, it will take some time to connect. Now just click and import the data. Okay, so I imported the CSV file. Okay, just you need to click on the import and select the location and tip or you can say the click on OK, and you will get that file inside the Google Colab, right? And just click on this three dot, copy path, and here you can write import this file, generate. Okay, now this data is imported. Now you can see, and even I will see the by df, as you can see the data is imported. And pandas, we know that actually we use to import the CSV file, and any file if we want to import inside the Colab or inside the Python platform, we need to import panda, right? And their matplotlib seaborn actually used for the data visualization. Now these are the data, their delivery distance, traffic congestion is given, weather condition, delivery slot, driver experience, number of stops, vehicle age, road condition, package weight, fuel efficiency. Okay, and the warehouse processing time and delivery delay. So this all the thing is given in this data set, you can see. So these are the one the thing. Okay, so now here delivery delay is means we can consider this particular feature as a dependent feature, or you can say the y, and remaining all are the x. With the help of that feature, we try to predict this label, means the delivery delay. So now what will be the next process we will do? So now we have the data set. Now this data I will divide into the two part. So what I will write, if I quickly see what is the my dependent variable, that I will consider as a y, right? So consider dependent, or you can say the y in short, as a delivery delay, and other as x. Now you can see x and y is created. X is your independent data, y is your dependent data. X means the delivery delay, y means except delivery delay, all the column it will consider as a x. That we know that except delivery delay is actually label, and other all are the feature. So that all the variable considered as an independent variable, that is x, and y means what we want to predict the delivery delay, right? And that is delay, yes and no, it's a categorical prediction. so that I'm considering as a y. So now what will be the next step? Once we create the xy, then divide the data into train and test. So now I will write split xy into the train and test. Now you can see we are able to divide the data into the train and test. Okay, now x train, x test, they are 80% data actually in the train, and the test they are 20% data, right? Now I will create the model with the k nearest neighbor, and I will explain before that what is the k nearest neighbor quickly. Now this particular algorithm work that I am trying to explain, k nearest neighbor, and just assume that the classification problem, and there is the two feature is given, age and salary. This is the x1 and x2, and this color is indicating yes and no. Just assume that the pink color is indicating customer will buy the service, or blue color indicate the customer will not buy the service. So now how this k nearest neighbor is work, that we will see. Suppose I have one this data, okay, this particular data set I have, okay, and now I just want to means I know with respect to the means one data there is the salary and age, and when I put that into the this particular graph, okay, and now you can see what is the nearest neighbor for this. If I consider k is equal to 1, the nearest neighbor is the pink, so you can say the customer will buy the service. Like that actually this algorithm is work. Just assume that this is the one data, okay, and it will check nearest neighbor 3, k is equal to 3, k is actually hyperparameter, and here 2 blue and the one is pink, so it indicate this particular point or this particular customer will not buy the service if suppose the blue is indicating the no, okay. So like that we can do the prediction, and here means first the algorithm will check the nearest neighbor, and that nearest neighbor number is the hyperparameter that maybe you can consider by hyperparameter optimization also you can identify. And once we identify the k, suppose k is equal to 3, and now you can say these are the nearest neighbor on the basis of the Euclidean distance, and it will give the output like the customer will buy or not buy. So blue is belongs to the not buy, then the result will be on the basis of the algorithm the customer will not buy our services. How it measure the distance? Actually you can see the distance measurement here, especially when we talk about the machine learning, so that KNN measure the distance on the basis of the Euclidean distance. Here you can see how to measure the Euclidean distance. Suppose this 2 point x2 minus x1 y2 minus y1 square, and this is the Euclidean distance formula. So like that actually it's work. Now suppose maybe the question how KNN regressor work. Suppose just assume that length, weight is the two independent variable, and on the basis of that I want to predict the one variable, that is the y. Okay, so here how KNN work. Suppose KNN means I am converting this all the thing, okay, into the point. Before that I'm just what I want to do with this algorithm KNN regressor. Suppose my length is 7, or you can say this particular product is length 7 and the weight is 8, and I want to do the prediction like what will be the cost, right? So that prediction how KNN actually do, so that we try to see, that is the one machine learning algorithm and how it works. So now here you can see, suppose I'm considering this data, I'm just converting this into the point, okay. So you can see I'm converting all the data into the point. Now I will measure the distance. So this is the distance. Now just assume that I'm considering k is equal to what? Just assume k is equal to 3. The 3 nearest neighbor suppose I am considering. Okay, so now can you tell me what will be the just I'm converting the thing equal to, now what are the nearest neighbor for this 7 8 point, means I'm measuring the distance like 10 50, how much away from this point 7 8, because I want to know this 7 8 belongs to the which class if the classification problem, but this is the regression problem. So first I will measure the distance from each point to identify the neighbor, right? So now these are the distance here mentioned, this all are the distance, right? So now the point is I just try to identify three nearest neighbor. So this is the nearest neighbor because the distance is very means you can say the low. Here you can say 7 9, distance from the 7 8 is only 1. The second minimum is, you can say, the 2 is the second minimum, and the third minimum is 2.23. So now how regression actually work? Okay, so I want to know at 7 8 what will be the prediction. So what the nearest neighbor 3 it will take, like here you can see the what is the nearest neighbor is the one distance actually, and what is the value of the cos for this 33, right? So 33 plus the second nearest is the 30 plus third nearest is actually 2.23 divided by 3. So you will get the 21.74, right? I'm sorry, it's not 2.23, actually 32. I'm sorry. 32, and now 31.66 is the prediction. Done. So like that actually means regression work, means k nearest regressor work. Okay, if k is equal to 4, then 4 nearest neighbor, then with respect to the level value we will take, and we will identify the mean or average of all the level value, nearest neighbor level value. Okay, now the next point is okay, we will solve that classification problem. Again, this is just theoretical part, how actually KNN work. Okay, so now I will go to the again Colab, and I will write here make KNN classifier, because we want to do the classification here. It's a classification problem, right? Means there will be delay or no delay, like that actually we want to predict. So make KNN classifier on X train and Y train. Model is ready, and here consider the n neighbor is equal to 5, that is hyperparameter. Okay, so even I can write okay, for KNN identify the best parameters with random search. It will just take 1 to 20 and then try to identify. Okay, and I'm just trying to identify the k. There are other parameter also, but I'm just trying to identify what is the best fit value for the k, right? Okay, so here just we try to identify the best k, and even we can consider the okay, so here n neighbor is equal to 3, so 3 is the best. Okay, so like that we can identify the best parameter with the help of the grid search. Okay, now even we can change this value, and also there may be other optimum value we will get. Okay, but now okay, so now I just want to do the cross-val and just try to check. Okay, if this I will change the value here, and neighbor is equal to 3. Okay, that will give me the good result. And now what I say, calculate the score of KNN. Now you can see the score. Now what I will do, So after the cross validation, you can see the accuracy is 73%. Now I will dump the model, and how to deploy that I quickly discuss. Dump the model, or you can write the specific model, KNN model. Okay, and you can see this KNN model is available. You can download in your local system. Okay, the next what I can do now, I just want to make the app file quickly, and then we will deploy and we can see the app. Okay, so make a Streamlit app and dump the app.py for the KNN dump model. Now you can see. Okay, and I'm just changing the feature name, and at the end I will deploy. Okay, this app.py file, there I will do some changes and I will deploy. That I will show you. Okay, so I will download both the file. Okay, so just log in the GitHub. Okay, and there I'm just as you can see, means app.py file that we just created in the column KNN model.save. That model we created, and requirement.text. So I will explain the app.py file. There I just changes the means column. Okay, so column name that mentioned in our data set that I given. Now you can see these are the means some changes I made. Okay, for the Streamlit app, and this is the app.py file. Even you can download from GitHub. Okay, and the second file is the KNN model, and third one, there only three things is required: Streamlit, pandas, numpy, and scikit-learn. So that I mentioned. Okay, so now I just try to make the app. How to make the app with a Streamlit, that I will show you. So just log in the Streamlit community cloud. Okay, so when you log in here, create app is available. Just click on the create app. Okay, then I have an app already I have available. Now you can see I will just select that file, and here I know app.py file name, and just click on the deploy. Okay, it will take some time. Okay, then you will see this type of the app you will get. Just click here. Okay, and yeah, it will take some time, but you will see the application. And one more thing, you can manage this corner. Manage app is available. You can see what the means if any error will come, you can solve. Now app is ready. You can share this app to anyone, and this is available on some public cloud. Now you can see I just passing the distance 12 kilometer. Here I am passing the 4. Traffic condition, weather is, suppose I am passing the 4. Delivery slot is 2. Driver experience is, suppose 10 year. The number of stops, that is 7. Okay, I'm just passing some random data, maybe 12. Here I'm passing the 120. That will be good. Suppose 7 stop. Vehicle age, I'm passing the 4. Road condition, I'm passing the 4. And package weight, I'm passing the 23 kg. Fuel efficiency, that we consider the 14 km per liter. Warehouse packaging will take 100 minutes. Okay, so now I just want to predict okay, there will be delivery delay. Yes, delay expected. So like that we can predict. Okay, in this particular case there is the delay expected, and this prediction means we make we already created the KNN means you can see the model. So we are doing the prediction on the basis of the historical data. Okay, on the basis of the historical data I can say there is the delay expected. Here machine consume the historical data, and on the by consumption we made the one model, right? That is the KNN model. And now on the basis of the model we are trying to do the prediction, and here predict delivery delay 1 is mentioned. Okay, so this is all about the application. Even I share the application video link. Okay, so this is all about, and quickly you can create this type of the app. This is the very easy, and with the Streamlit app you can deploy, but you need to create the GitHub account as well as the Streamlit account. So this is all about means you can say the KNN algorithm, or as well as we are trying to solve some supply chain problem, on time delivery, we are able to deliver or not in a particular situation, so that all the thing we can predict on the basis of the historical data. Suppose I'm just changing the values, and now I will see there is the delay expected. Okay, and now if we reduce the warehouse processing time, in that case here you can see there is no significant delay expected. So like that we can see what means we can give the recommendation as well as we can predict there we are able to deliver on time or not, and what the changes we can do so we can deliver on time. So that prescriptive action also we can take with the help of this machine learning model. So this is all about today's session. Thank you.